So I will present the Kalimucho project. The objective is to make a platform to allow development of applications on various devices like sensors, tablets, smartphones, and standard PCs also. Applications are Java and made of Java components, and these components are linked by flows of data. And Kalimucho can change the architecture of the application while it's running without stopping it. That's the objective. Why a platform? Well, for embedded applications, it's very difficult to make adaptation. We can only make self-adaptation, and self-adaptation means heavy application because the application needs to have all the possibilities inside, embedded. Our solution is components of the application are downloaded and removed. Downloaded when needed and removed when not used. So we have only what is needed at one time. Components are created, removed, and moved, migrated without stopping the running application. That means evolution of the application. And communication between components are totally transparent. They send and receive data, but they don't know where and from to. The platform decides where data go and from where the data comes. So applications are made of services, and an application is a set of services, of course, and services are made of assemblies of components. So a service is some components with links. And a component is a light component. That means it made only one thing. So it had some inputs and only one output. So the deployment and the reconfiguration of applications allows to add a user, remove a user dynamically, add a service, remove a service, or modify how a service is done. And we want to make a dynamic adaptation to the context, to the user, and also to the usage of the application. So our applications are like that. Some components distributed on some devices and links. Each component has no input or as many input as we want, and only one output, but the output can be duplicated and sent it to more than. I will take a little example to show what we want to do. An organism that takes care of our environment can send an agent with a smartphone, of course, on the scene of an environment accident. What we want is when it arrives on the scene, the agent can send a video in a streaming mode to the center. Then the center wants this video to be sent to an expert who is not here but is at home with his smartphone. Then the expert decides that it's important to get picture, to make a file, to ask for money to the European community or so on. And to complete this information, the center wants to have the GPS position exact of each picture. How can Kalimucho help to do that? Well, arriving on the scene with the center with a traditional PC and the agent with a smartphone, we send some commands to the platform and a command to create a component. So the component is created on the smartphone, then a command to create a connector. The connector is created, and then a command to another component, and then the video is captured on the smartphone and sent to the center. Later, we want to send this video to the expert, so we send a command to the platform that says send component from this to this, and the component is migrated, the connection is redirected, and the the applications go on working. Later, we will stop the video, stop the video display, remove the connector, and then start new components to send pictures from the smartphone to the center and the expert smartphone. And if we want to add a GPS position, we only need to create a new component, create a new connector, and that's all. Well, in this example, all decisions were because of utility. We want that, then we want another thing. But what the objective of Kalimucho is also is if the platform sense that the quality is bad when sending a video because the network is not good or so on, it can decide by itself to stop the video and start pictures because the video don't work and picture will work. But later the platform sees that the network works well, it can stop the picture and go back to the video. That's what we want also to do. Well, how did it work? In more details, if we take this part of the example, the deployment of two components and a connector, what happens? Well, the platform of the agent smartphone receives this command, so with a language for the command. Then it tries to find the code of the component, because the code, the byte code of the component is not downloaded for the moment in the smartphone. So he sends a broadcast message looking for this code. And one of his neighbors can send the code. So the code is sent and the smartphone can download it and start it. If no neighbor can send the code, so the request is broadcast one more time by each neighbor in order to try to find this code. So in this example, there is a code repository which sends the code, and the code is relayed to the smartphone. Well, the component is now created on the smartphone. In order to continue, we have to create a connector. Then to create a connector, the smartphone will try to find a route to the center. So he sends a message like a ping message, and he gets a reply, all well. So then the platform sends a command to create the connector, and the two parts of the connector are created, and the link is established. Well, what can happen is you send a ping message and there is no reply. So if that happens, the platform will send a broadcast message looking for how to find the center. It works in the same thing. Every neighbor that gives this request will try with a ping message. One or two or more add a reply, and then they reply that they can do relay. They can relay for the center. The smartphone will choose one relay, send it a command to create a connector, then it sends a command to create a connector, and we have a connector, not direct, but a working connector between the two. Last, the video display component need to be created on the PC, so it's the same thing that we have seen for the first component, and the application can run. If we take the problem of how to move a component from one device to another device, what happens? So for the moment, we have this situation. We send a command to the platform on the PC in order to send the component to the other smartphone. What happens? It stops the component, it gets the state of the component, and then it looks for a route to reach always the same thing, and then it will send the component as a serialized component, a Java serialization classical. Well, but the problem is that the code, the bytecode of this component is not in this smartphone. So he had to look, as seen before, to find the code. He finds the code, and when he gets it, he can get the serialized component and start it. But the connection is not yet good from this way to this way. So the platform will send a command to redirect the connector, and the smartphone will find a route, another way to the other, and the connector is redirected and the application goes on. Well, we have a command language, a simple command language to create a component, to remove a component, to send a component to another device, to disconnect an input, to disconnect an output, to reconnect an input, and to duplicate an output. We have some commands for connector, create, remove, redirect input, redirect output, and some commands also for context. Read state means read the state of the host. The state of the host is how many free memory, how CPU load, and battery also. The state of a container, that means, for example, for a connector, we can have how kilobytes are sent by seconds and so on. Well, the total architecture of the platform is this one. We have the local part of the application, that means the components working and the connectors, and we have a part of supervision that can stop components, start, move, etc. We have a context capture that captures context from the application and from the hardware, battery and so on, and a decision module that can say it's time to change this configuration because it doesn't work well. But for the moment, the decision module is not yet implemented because we are working on it, but it's not yet terminated. So what we do, we have done a test module. Here, hop, non, bon, tant pis. Voilà. Là, je suis mal. Je reviens à l'arrière. Hop, hop. A test module that replace the decision module, and we can test the functioning of the platform, but only with files, with commands. We prepare some commands and we start them to see what happens when these commands are executed. Well, the platform is made of a lot of services, internal services or services more usable. We find the services for network, find a route finder, a kind of DNS, not really a big DNS, but a DNS. Each platform knows all its neighbors, the address, and the clock shift between the two devices, and network communication layer, two layers, one independent of the network and the other dependent of the network. Then the part of command execution, we call it supervisor. The part of code management, repository manager, code loader, and class manager, and the part of context management, host, sensor, and context manager, and services for applications, hardware access like GPS and so on, and the containers for components. And service management, which registers all the services. Well, the content manager controls the hardware.